the bottom line is that the speed of light is a constant. And I'll bet on this one. A lot of people try to prove it's not, but I haven't seen a decent proof yet that it's not a constant. So, the further an object is away from the Earth, the older the image of the object. So in this particular case, when we look at Proxy Centauri, that's 4.5 light years from Earth, which means that the image we see is 4.5 years old. In the case of the Andromeda Galaxy, you're looking at something that's 2 million years old because it's 2 billion light years from the Earth. So, if we know how far stars are from us, we can tell how old their image is, and therefore we can tell whether or not there was starlight back then. Alright, now this is something that a woman named Henrietta Leavitt did at the Lowell Observatory in northern Arizona. She showed that a particular type of star, which is called a Cepheid variable star, you can measure the distance of that star by measuring the periodicity of its light. What happens in this particular case is a Cepheid star is a star that basically has burned up all of its hydrogen and is now burning helium. And the atmosphere of a Cepheid star is, of course, helium. Well, there are 3 ionization states for helium. Helium plus 2, helium plus 1, and helium 0. Now, 0 and 1 are transparent. You can see through them. Helium plus 2 is not transparent. So it causes the light to diminish to a minimum. And the size of the Cepheid star tells you what this period is going to be, as is plotted over here, the period and the luminosity. So the basic idea is that if you get a certain period for a particular Cepheid star, you can extrapolate back on that curve and find out what its luminosity should have been, and then you look at the luminosity that you're seeing in the telescope, and that tells you basically how far the star is. Now, when Henrietta Leavitt was doing her stuff, she was looking at Cepheid stars in the Large Magellanic Cloud. And she found that the Large Magellanic Cloud was like 160,000 light years away or something in that neighborhood. It's in the vicinity of our galaxy. Of course, one of the things that you do in science is you go back and you do the experiment again when you got better instruments. Well, the Hubble telescope came along, and of course they did the experiment again, and those are the results. Okay, so how long has starlight been around? Well, this is a 10 billion year old supernova. Right there. The oldest Cepheid star, by the way, or the furthest Cepheid star, is 94 million light years away. So we know that this has been going on for 94 million light years, or 94 million years. This particular supernova is 10 billion light years away. And so we know that there was starlight 10 billion years ago. And finally, you see these little, this is where this is going to come in handy. See the little circles here? Little blue dots in the center of each of those circles? Those are the oldest known galaxies in the universe. Seen in the Hubble Ultra Deep Field. And those guys are 13.2 billion light years away. So we know that there was starlight 13.2 billion years ago. So the bottom line is that the electroweak process has been going on all of that time. And therefore, when the potassium-argon dating tells us the oldest rocks on Earth are 4.2 billion years old, you can take it to the bank, because the meter stick has been around for 3 times that length. Okay, so you have a long list of things that we know, and the bottom line here is we know that the electroweak is necessary for starlight. We know that starlight has been around, so we know that the electroweak process has been around, and therefore we can use it to date using potassium argon and carbon-14 dating. And the potassium argon dating tells us that the oldest rocks that formed on Earth are 4.2 billion years. The meteorites that came from Mars and the Moon are 4.56 billion years. And of course, potassium argon tells us that Bishop Ussher discovered genealogy and not the beginning of the Earth. So any questions? I went a little over time. The age of the Earth. Yeah.
Well, what points do people who do not believe in this type of dating mechanism, what points do they bring in to try to argue against that?
The people who refute this are people who base their beliefs on their religion, quote, unquote. The begets in the Bible. But, you know, the first question that I ask anybody who holds to that is, show me the chapter and verse in the Bible that says the earth is 6,000 years old. And the answer to that question is they can't do it. And the reason they can't do it is it's not there. It dates back to 1654 with Bishop Ussher that this idea came into existence. And Bishop Ussher didn't know about electroweak forces. He didn't know about nuclear decay. He didn't know about any of this stuff, so he was not equipped to really answer the question. The begets of the Bible only tell you when people started writing down people's names. Any other questions?
There was a lot of begetting.
Yeah, there was. Figure 20 years times, 5 per century, and he's saying that there were 60 centuries, so that's 300 of them.
So what year do you think Adam and Eve came?
How should I know?
But you did Earth and you didn't do people.
No, because really people are not relevant to the question. The age of the Earth is not somehow tied in with the existence of human beings. Human beings probably date back maybe 1 million years to Lucy and the Olduvai Gorge.
2.5 billion?
No, not even close.
No.
1 million, maybe 2 million at the outside. The most primitive ancestors, probably 1.5 million. So we haven't been around that long. Any other questions? Yeah.
So did you say that the moon is older than the Earth?
Not really. It probably formed at the same time. But you see, the Earth went through a period where it was a big molten ball, and so was the moon. And because the moon is smaller, it solidified sooner. And the rocks that were formed on the moon at a slightly earlier time. And the same thing is true of Mars. The moon is 1/6 the size of Earth. Mars is about 1/3. So you do the math and you can figure out, yeah.
Okay, older than that, what can you figure today too?
Older than that?
Yeah.
What do you mean? You mean if there were rocks that are older than that with carbon?
In a molten state, it would have been earlier than 4.5.
It could have been. It could have been. The samples that we have are 4.2. And we figured 300 million years for the Earth to go from its radioactive molten core to something resembling a rock. And those rocks in South Africa, Canada, and Australia date back to this 4.2 billion year period. So those are the oldest rocks. And there may be things on the planet that we don't know about yet that are even a little older, but I kind of doubt it. I think that this 4.2 to 4.5 billion is probably right on the money. Plus or minus 100 million years, I mean, who cares? Any other questions? Have we run out of time yet?
No, there's 2 minutes left.
2 minutes. No more questions?
I've got $1,400
You
myself.
prophesy how long the earth will last in any way.
Well, I know how long the sun is going to last. It's about 5 billion years, and the sun will become a red giant and will swallow the earth. So you can figure the earth has about 5 billion years left.
Billion or million?
Billion.
With a B.
Yes, with a B, and the sun has been around already 5 billion years, so it'll be a 10 billion-year-old star when it swallows